Hello friends, welcome back to CSharp.net online training video series. Now I am going to discuss generalization and specialization in CSharp. These are two important terms. These two terms are also related to inheritance. As a developer, as a programmer, you should understand these two terms in detail. Right? I know many fresher level developers, many beginners, even though some of the experienced developer, they do not know this concept in detail. They are getting confused. What is generalization? What is specialization? How we can implement generalization and specialization in our application development, right? So what I'm going to do, I'm going to explain each concept. I'm going to explain generalization by taking two different kind of real-time examples. I'm going to explain specialization by taking two different kind of real-time examples. I will try my best so that you can easily capture these two important concepts. Let's start the discussion with specialization, right? Please have a look at this image, right? So let's assume we have a class called rectangle. Then we create, then can we create an object of the rectangle class? Yes, as it's a class, we can create an object of the rectangle class. And once we create the object of the rectangle class, then we can consume all the public members, right? Or if you are creating the object from outside the class and all the members, right, within the class, you can consume. So you can consume the members means you can consume the data members as well as member function of that rectangle class. Let's say you have another class. Let's say you create another class qubit, and that qubit class is inherited from the rectangle class. You can see this is your rectangle class. This rectangle class having some data member and member function. Then using that rectangle object, you can consume them. Then you are creating another class qubit, right? And this qubit class is inherited from the rectangle class. Now using qubit class, you can consume the member of qubit class as well as you can consume the member of rectangle class, right? So two things, right? These are two things, rectangle and qubit. Really they exist in the world? If I ask you, qubit is exist in the world, rectangle is exist in the world, right? Can you show me a rectangle? Yes, you can show me the shape of some shape that are rectangle, or you can also say paper which is a rectangular shape. So rectangle exists in the world. And what about qubit? Yes, it is also exist in the world. Any box size shape you can show me and you can say that it's a qubit. So these two things are exist in the real world, right? Now if I say which one is existing first in our example, in this example, which class is exist first? Which class is exist first? Then the answer will be a rectangle, right? And from the rectangle class, we are creating the qubit class. So the rectangle class is the first class, then qubit class is creating from the rectangle class. So the rectangle class is already existing, and from the rectangle class, we are defining a new class with some extra feature. And whenever you create a new class from an existing class, then that new class is nothing but a specialized form of the existing class. So in this case, this qubit class is a specialized form of the rectangle class. This is nothing but specialization, right? Now let us understand, right? So what I'm doing, okay, I'm just copying this code. I'm pasting it on my Visual Studio window, right? So now you can see this is your rectangle class. This rectangle class is exist in the real world. You can show me some shape, or you can show anyone some shape, and you can say this is a rectangle class. And this is a qubit class. You can also say show some shape, right? And you can say that shape is a qubit, right? So this rectangle and qubit are existing in the real world. And here in this example, this qubit class is created from the rectangle class, right? So what it means? It means this rectangle class having some properties, and this rectangle class share these properties to its child classes. Here qubit is a child class. This child class not only having this member, but also having those members which are already defined in the rectangle class. So here rectangle class is basically designed, basically sharing something, right? Some existing thing to a different class. Here qubit is a class, here rectangle is a class, right? Qubit class existing the properties and data member and member function from the rectangle class. Now using this qubit class, you can create an instance and you can create the members, right, which are not only defined in the qubit class. You can also consume the member which are defined in the rectangle class. Now come to this main method. See here, I'm creating an instance of a qubit class. Once I create the instance of a qubit class, you can see I'm consuming the value, I'm consuming the area, and I'm also consuming the perimeter method. If you look at the definition of a rectangle and qubit, so this volume method is defined in the qubit class, but this rectangle, this area and perimeter method are defined in the rectangle class. So using the child class instance, you can consume the member of a parent class as well as child class member that we already discussed in our inheritance relationship. And here, qubit is a specialized form of a rectangle, right? This rectangle class exists and this qubit class exists. So this rectangle class consuming and inheriting some of the feature of a rectangle class. Whenever you are making the inheritance relationship, and if the parent class exists in the real world, as well as if the child class also exists in the real world, then such type of inheritance, you can say, so this is a inheritance altogether, but in this case, we can say this qubit class is nothing but it's a specialized form of this rectangle class, right? Now, if you are getting confused, let me give you one real-time example so that you will get more idea, right? So let's take another example. So cars. So we have a class called Innova. Let's say Innova is a car, and this Innova car is developed by a company called Toyota, right? And then there is another called Fortuner, and you can say Fortuner is a class, and this Fortuner class is inherited from the Innova class. So if you know about these two cars, then you should know that first the Toyota company introduced the Innova car, right? And then they introduced a new car, right? And this new Fortuner car, it is nothing exactly a new car, but you can consider it's an extension of the Innova car, right? So if you so a common man, if you see, right, Fortuner is an extension of Innova that is having same seating capacity but with a lot of extra feature compared to Innova. So it means that the Fortuner car is an extension of the Innova car. So Innova car is existing, Fortuner car is also existing. Innova car comes to the market first, then the Fortuner comes to the market. This Fortuner car is nothing but it's not a completely new car. It is basically based on this Innova car, right? So some of the features which are available in Innova car, you can find in the Fortuner car, but with some additional functionality, right? So whenever you are creating a class, right, from another class, and if that another class is already existing in the market, right, then if this new car what you are creating is nothing but it's a specialized from that existing class. This is what you need to understand. So here Fortuner is nothing but it's an specialized form of Innova, right? So here Innova is a base class and Fortuner is a derived class. Innova was already existing and Fortuner is the specialized form of Innova. This is nothing but specialization. So what exactly mean is something is already existing and then we are deriving something from that existing one by adding some extra feature. Something is already existing means Innova is already existing, and then we are deriving something from that existing one. So we are deriving that something which is already existing in the Innova car inside the Fortuner car by adding some extra features. And when you are doing this kind of implementation, this is nothing but specialization. This is altogether inheritance only, but in this case we can say that this Fortuner car or this child class is nothing but a specialized of Innova or the parent class. This is nothing but specialization in C#. Now let's come to the other important topic that we are planning to discuss today. What is generalization, right? Let's say we have three classes that are square, rectangle, and circle. Then for all these three classes, we are defining one class that is shape. And shape, rectangle, circle are inherited from the shape class. You can see this image. So here we have one class called square. We have another class rectangle. We have another class called circle. And all these three classes are inherited from one more class that is called shape. So among these classes, which one is existing first? So if I ask you which one is existing first, then we all know that square, rectangle, circle, all are existing in the real world, right? We are calling them shapes. So square, rectangle, and circle all are existing in the real world only, na? But we are calling them as shapes, right? So do you think that shape really exists in the real world? No, it is just a virtual term, right? If I ask you to show me some shape, then you will be drawing a rectangle or a circle or a square or a rhombus, etc. but you cannot show me exactly a shape. If I'm asking you to show me shape, then you might be draw a square, or you might be draw a rectangle, you might be draw a circle, right? But you cannot show me just a shape. So shape is nothing but a generic term you can say which represent all these things, right? Or you can say it's a generalized term which is not existing in the real world. So these classes, these child classes, which are already existing in the real world, right? So in this case, square, rectangle, circle, all these are existing in the real world. What to bring all these existing things into a common platform, we have given the terms here. So which is nothing but the logical term, the virtual term, and it is not a real term. It doesn't exist in the real world, right? So can you find the area of a rectangle? Yes, we can find the area of a rectangle. Can you find the area of a square? Yes, we can find the area of a rectangle, square. Can you find the area of a circle? Yes, we can find the area of a circle. Yes, every shape has an area and every shape has a perimeter method. So this is a common feature. So what we have to is, so we need to bring all those common feature inside the shape class, right? So now you can calculate the area and the perimeter of shape. So if I ask you, can you calculate the area and the perimeter of shape? No, you cannot calculate. But if I ask you, can you calculate the area and perimeter of square? Yes, you can calculate. If I ask you, can you calculate the area and the perimeter of a rectangle? You can calculate. But if I ask you, can you calculate the area and perimeter of shape? You cannot calculate because the shape doesn't exist really in the world. Na? Then what is a generalized means that to bring all these existing things. So I'm saying things means you can consider all these existing objects into a common platform. That common platform is nothing but here shape. And whenever you are bringing all these existing things into a common platform, which not only which is not exist in the real world, then that thing is going to be called as generalization. So you can say square, rectangle, circle are nothing but generalization of shape, right? So this is what you need to understand, right? Okay. So to make you understand what I'm doing, I'm taking another example. Suppose you have Innova, BMW, and Audi car. So you can you can start the car, you can stop the car, accelerate, change gears. In all these cars or not? Then what are all these? This BMW, Innova, Audi. So what are all these? These are only cars, na? And these cars are physically available in the market. All these are nothing but cars. So they are all inheriting. Now if you look at this image, so this BMW, this Innova, this Audi, all are inheriting from the cars. Then what can you do in a car? You can drive, you can start up, you can change gears. All these things, all these features are available in these cars. Then what about car? Does car really exist? No, it is just a generic term. It's just a virtual term which doesn't exist physically in the real world. Just a general term, or you can say it is the logical definition of a group of things. Then what is the group of things in this example? Cars, Innova car, BMW car, Audi car. These are physically exist. These are the things which are grouping together, and once we group together, then we are giving a logical term, or we can giving a general term, or you can give a virtual term called cars. So we have given a superclass to a group of classes for referencing, right? So in this case, this is nothing but your superclass, right? And we are giving this superclass to a group of classes. So Innova, BMW, Audi, these are nothing but a group of classes, and these group of classes are inheriting from this class called car. So it is just like if I'm looking at Innova, so I can say that it's a car. If I'm looking at BMW, I can say it's a car. If I'm looking at Audi, then I can also say that it's a car. So any four-wheeler, we use the term car. So we are using this term generalization for referring them. So you can see here the generalized term is car, and this generalized term is nothing but it is basically used to refer the group of things, right? If I'm looking at the things, then I can say this thing is nothing but it's a generalized form of car. Innova is a car, BMW is a car, Audi is a car, right? So we do not have to know the brand name and the product name perfectly. We do not need to require that what is the brand name of this car, what is the brand name of this car, right? What is the product name of this car perfectly. When it looks like a car, then we can say it's a car. So in the real world or in our daily life, we are using some things frequently, right? Now let us understand these things with one example. So what I'm doing, I'm just copying the code and I'm pasting it in the Visual Studio. So you can see this is iCar, right? This iCar doesn't exist physically, right? But this is Innova. This is BMW. If I want to say Innova is a car, then it should have all the features that are available inside a car. If a car having start, stop, right, and if it looks like a car, then we can say it's a car, right? So in this case, this iCar or car, you can say it's a generalized term for Innova, for BMW, or for any other classes. If you look at the Audi, BMW, or Innova, Fortuner, right? All these things are nothing but car only. Na? So here the generalized term is car. But in this case, that generalized term, what we are using for Innova doesn't exist physically, right? Doesn't exist physically means this car you cannot create an instance because it is not exist physically. But this is exist physically, you can create an instance of Innova. This is exist physically, you can create an instance of Innova. See, here I'm creating an Innova class instance calling the start and stop. Here I'm creating an instance of BMW class and I'm calling start and stop. But I cannot create an instance of this because it is not exist physically, because it is just a generalized term which is referred to Innova and BMW. But if you look at the specialization, both are existing, right? You can say rectangle class is exist, cuboid class is exist. Means what? Means you can create an instance of a rectangle class. You can create an instance of a cuboid class. So these are exist physically. And if you come to the second example, Innova, it is also exist physically. Fortuner, it is also exist physically. So this is nothing but Fortuner is a specialized term of Innova. Here, this cuboid is a specialized term of a rectangle. Rectangle exists physically, cuboid is also exist physically, but cuboid is created from the rectangle. Some of the properties are rectangle sharing to the cuboid classes. So in this case, some of the properties or features Innova sharing to the Fortuner classes. But in this case, the shape class doesn't share anything to square, rectangle, circle, right? So what is it? It is a generalized term which is referred to square, rectangle, and circle. In this case, car is nothing but it doesn't provide anything to these child classes. Rather, it is just a generalized term for Innova, BMW, and Audi classes, right? So this is what you need to understand, right? So now, what is the summary? Summary in the sense, let us summarize the generalization and specialization. So the point that you need to remember is both generalization and specialization achieve only using inheritance, right? Without inheritance, this is not possible. We have seen, for example, in which two are specialization and two are generalization, right? For specialization, we have seen the example of a rectangle and a cuboid, as well as we have seen the example of Innova and Fortuner. And for specialization, we have seen the example of SIP and the example of cars, right? In specialization, the parent was existing and child was defined later. That means what? Now both parent and child are existing in the market. Parent exists first, then child is defined from the parent, right? But in generalization, the child class was existing in the real world, right? The parent class doesn't exist in the real world. First the child classes are existing, and based on the child classes, to group all these child classes together into a common platform, we are defining the base class, right? So that means the specialization is a top-down approach and the generalization is a bottom-up approach. Top-down approach means first parent class exists, then child class is created from the parent class. And bottom-up approach means the child classes are existing first, then based on the child classes, we are grouping those child classes under a common platform. That means we are creating a base class based on the child classes. So this is the reason we are saying this is bottom-up approach. In specialization, the base class has something to give to the child classes, right? You can see the base classes has something to give to the child classes. If you look at the example, right? So you can say this is the rectangle class. This rectangle class having something in length, breadth, area function, and perimeter function, right? And these functions are given to the child classes. So you can create an instance of the child classes, you can see, and you can construct those methods and properties. That means in the case of specialization, the parent class giving something to the child classes for consumption, right? Whereas in generalization, the base class or the parent class doesn't have anything to give to their child classes. Now, if you look at this class, so this is just a declaration. He is not providing any implementation. right? The implementation to be provided by the child classes only, right? So in this case, the superclass or the base class doesn't give anything to the child classes for consumption, right? Okay. Just their purpose is to group them. So what is the meaning of generalization? Means to group the child classes under a common platform, under a common name. And that name might be your car, that name might be your cell. The purpose of a generalization is to achieve polymorphism that we will discuss in our coming session, right? And the purpose of specialization is to share its features to its child classes. So there are two purposes of inheritance. One is to share feature with child classes, and the second one is to achieve polymorphism. Right now, I hope you understand what do we mean by specialization and what do we mean by generalization. But behind the scene, both are going to be achieved by using the term or by using the concept called inheritance. Without inheritance, generalization and specialization is not possible. Thank you. Thank you for watching this video. If you like this video, please subscribe to my YouTube channel.